Welcome to Spring LIB.
We want to determine what the volume of H2 gas is that we produce when we electrolyze a sodium chloride solution. We are told that 257 liters of Cl2 gas is produced, and also that both volumes are measured at the same temperature and pressure of 50 degrees Celsius and 2.50 atmospheres. So these are the two half reactions that are taking place. We start with sodium chloride solution. So we have Na plus and Cl minus ions in aqueous solution. So that's how we know that we have to convert those Cl minus ions into Cl2 gas, since we know we produce 257 liters of Cl2 gas. And based on the table for the standard reduction potentials with their corresponding half reactions, this reduction reaction produces H2 gas. So that's how we know these are the two half reactions that are taking place. And we also know, again, that this is an electrolysis of sodium chloride. And we know that for electroplating problems, we are usually given a time that we run a current through that solution. That time could be given in units of seconds. And we know that when we run that current through it, current has units of amps or coulombs per second. So if we multiply the time by the current in units of coulombs per second, then units of seconds cancel out, and then we convert using Faraday's constant 96,485 coulombs per 1 mole of electrons. So then we cancel off units of coulombs, and then we relate how many moles of electrons are involved in the production of, in this case, Cl2 and H2 gas. We see, based on the stoichiometry of both of our half reactions, that in either case, 2 moles of electrons react with 1 mole of Cl2 and 1 mole of H2. So therefore, the ratios are the same. We know that 2 moles of electrons correspond to 1 mole of either Cl2 or H2. And now we cancel off units of moles of electrons. And so now that we have fully converted into the total number of moles of either Cl2 or H2 gas that we have produced, we see that everything else being the same, meaning the current that we run through it and the time frame, that based on the stoichiometry, since this ratio is the same for either gas, then the number of moles that we produced, which we can call N, is the same in each case. And now to convert that amount of moles into volume for a gas, we know we use the ideal gas law, PV equals nRT. And the volume is therefore equal to the number of moles times the ideal gas constant, R, times the temperature, divided by the pressure. We just saw from this dimensional analysis that we have the same number of moles of gas being produced based on this identical ratio for each one of those gases. R is a constant, and again, we are told in the problem statement that we are at the same temperature and pressure for each one of these gases. And so because all of these terms are the same for both of the gases, then that must mean that the volumes of the gases that we produce are equivalent, and we are given the volume of Cl2 gas that we produce to be 257 liters. And so therefore, the volume of H2 hydrogen gas that we produce must be equivalent to that. So therefore, the volume of hydrogen gas that we produce must be equal to 257 liters.